In our previous lecture video, we were discussing on addition of vectors. We discussed two laws. One is general law, then the other one is triangle law. In this lecture, we will discuss about law of parallelogram. This is the most important law in these vector lessons. This law states if two similar vectors, we should note this point, two similar vectors, like similar vectors means two vectors should be velocity or should be force. But here's the thing, the vectors should be similar. If I take velocity, all the vectors should be velocity. If I take force, all the vectors should be force. If two similar vectors acting simultaneously at a point, this is one of another important things, simultaneously at a point, can be represented both in magnitude and direction. By the help of this law, we can have the magnitude and the direction by two adjacent sides of a parallelogram. If these two vectors can draw a parallelogram, then the diagonal from the point of intersection, this is the point of intersection, of these sides gives the resultant vector both in magnitude and direction. Now, briefly discuss this parallelogram OABC. Suppose two vectors P, this is the vector P and this is the vector Q, are acting the same time at a point. These two vectors P and Q are acting at the same time at a point O. This is the point of acting, the point O. At an angle alpha, the angle between this P and Q are, suppose we take this as alpha. Now, according to the parallelogram law, the diagonal, this diagonal from the tail points of P and Q, like the tail points here is this point, tail points of P and Q represent the resultant vector R. So this is the resultant vector R. So we can have, if we know the diagonal, the value of this diagonal, then we will have the magnitude. But what we will have? We will have the magnitude. Magnitude. Also, with respect to P, we said that this is an angle of theta. So if we can find out this theta, then you can also have the direction. So this parallelogram law gives us as well as magnitude and direction. Now we will make a formula how we can calculate the magnitude of the resultant. So this is a vector P and this is the vector Q and this is our resultant vector R. This is our resultant vector R. Now from the point B, let us draw normal BN on the extended line of OA. So we extend this line OA and draw a normal from point B to A. From point B to A. Like give me a time. I should draw this clearly. So the BN is perpendicular to of ON. So this is the perpendicular of ON. Now, as we know, these two sides are parallel and we take the angle between this P and Q vector as alpha. So, as these two are parallel to each other and the OA is the intersect of these two OC and AB, as we can say that AB is parallel to OC and ON is the intersect. ON is the intersect. So So this is the alpha cone. So by the help of this parallel law, we can also find out that this is also alpha. This is also alpha. Now give me a time to remove these things. Okay. Now again, from the law of Pythagoras, we take this triangle OBN. We take this triangle OBN, and by the help of Pythagoras law, we can say that the OB square equals to BN square plus ON square. BN square plus ON square. Also, we know that ON means OA plus AN. So we can write BN square plus OA plus AN whole square. Now we divide this, we break this OA plus AN whole square. So we will get BN square plus OA square plus AN square plus 2OA into AN. 2OA into AN. Now coming another thing, like now we take the triangle ABN. Also we will put the law of Pythagoras. Here we can find that AB square equals to BN square plus AN square. BN square plus AN square. Also, we know that AB equals to OC. So we can write this thing as OC square equals to BN square plus AN square. BN square plus AN square. Again, from this triangle A, B, and we can say that cos of alpha equals to AN by AB. Cos of alpha equals to AN by AB, or we can write this AN equals to AB cos of alpha. AB cos of alpha. So now coming to these equations, here we can write, give me a time, we can rewrite these things like this way: AN square plus BN square plus OA square plus 2OA into AN. From this equation, we can say that BN square plus AN square equals to OC square. So we can write OC square there, and for AN, we know that AN equals to AB cos alpha. So here you can write OA into AB cos of alpha. We also know that AB equals to OC as their parallelogram. So we can write OC square plus OA square plus 2OA into OC cos of alpha. So now, as OB is the diagonal of this parallelogram OABC, so we represent this diagonal OB as R, and we know the two vectors represented OA equals to P and OC equals to Q. So instead of OA and OC, we will write P and Q. So that will be R square equals to OC should be Q square, OA should be P square, and 2PQ cos of alpha. So this is the formula where we can calculate what is the magnitude of these P and Q vectors which are acting at the point O at the same time. So by the help of this law, R square equals to Q square plus P square plus 2PQ cos alpha, we can calculate what is the magnitude of this resultant vector R. Now let us find out what is the direction of this resultant vector. Direction of this resultant vector. Give me time to draw this parallelogram, and this is the alpha between the two vectors P and Q. With respect to P, the resultant vector are acting at a point theta with respect to P. With respect to P. So we will find out the angle with respect to P of the resultant vector. So first of all, I write the formula. If I want to determine with respect to P, then the resultant vector theta equals to tan inverse, as I take this as with respect to P, then this should be P and other vector should be Q, and I write a plus between P and Q, and on the upper side I will write, give me time, sine alpha by cos alpha. So this is the formula of finding any direction with respect to any vector or any other vector. Now we will find out, we will prove this theta equals to tan inverse q by q sin alpha by p plus q cos alpha. In the triangle O B, and we can write tan theta equals to, this is the angle theta, tan theta equals to Bn by On, Bn by On. And we also know that this is an angle of alpha. This is the angle of alpha. So from the triangle OAN, we can write sine alpha equals to Bn by An. Like Bn by, not An, it will be AB, and cos alpha equals to An by AB. Now from, instead of Bn, we will write AB sine alpha, and instead of On, we can write, we will write OA plus An, OA plus An, or we can write this AB sine alpha equals to OA plus, instead of An, we can write AB cos alpha. So we can write, instead of AB, we can write OC. So here we will write OC sine of alpha OA plus OC cos of alpha. And we know that OC represents the vector Q and OA represents the vector P. So we can write this thing Q sine alpha divided by P plus Q cos of alpha. So we can write tan theta equals to Q sine alpha divided by P plus Q cos of alpha. So this is the, and this theta represent the angle between the resultant vector R and our respected vector P. So by the help of this formula, we can find out the direction of the resultant. Now consider some special cases. We know our vector, the magnitude, the formula of our parallelogram law is r square equals to p square plus q square plus 2pq cos of alpha. So here, if we change alpha, then there will be some certain cases that are necessary to understand. Like if we take alpha equals to 0 degree, then we know cos 0 equals to 1. Then r square should be p square plus q square plus 2pq cos 0 degree, or we can write this thing as p square plus q square plus 2pq, or we can write this thing as p plus q whole square, or we can find out this r equals to p plus q. So this is the maximum of resultant. Maximum. Now we can say that if two vectors are acting at an angle of 0 degree, then their resultant must be maximum. So take an example. If this is a vector p and this is a vector q, and the angle between this p and q vector alpha equals to 0 degree, then the resultant of this vector will be maximum, and this vector, the resultant will be the addition of these two vector. This is an special case. Now please give me some time to remove this thing. Now take alpha equals to 90 degree, and we know that cos 90 degree equals to 0. So we can write r square equals to p square plus q square plus 2pq cos of alpha, or we can write this thing as p square plus q square. As cos alpha equals to 0, then the whole term should be 0. The whole term should be 0. So when the two vectors acting at perpendicular to each other, then the resultant must be this. And to find out this resultant, we will write this thing as p square plus q square, root over of p square plus q square. Now take an example. Let me remove this thing. Now if alpha equals to 180 degree, then the resultant r square should be p square plus q square plus 2pq cos of 180 degree. We know that cos of 180 degree means minus of 1. Cos 180 degree equals to minus 1. Then this should be p square plus q square minus 2pq. So we can write this thing as r square equals to p difference q whole square. P difference q whole square. If p is greater than q, then r equals to p minus q whole square, or if p is less than q, then r square will be q minus p whole square. From that we can write that r equals to p difference q. This is the minimum of resultant. So this is this is another special case. If two vectors acting at an opposite side, like this is a vector p and this is a vector, this is a vector q, this is a vector q, this is a vector p, and they both acting opposite sides, and the angle between this p and q are 180 degree. Then the resultant must be minimum. The resultant must be minimum. That's all for today. In next lecture, we will solve two math problems of vector. Subscribe to the channel to get more update videos on vectors. Thank you.